In today's video, we're going to talk about constructing confidence intervals for difference in sample means. This is fairly simple and very similar to constructing confidence intervals for a difference in proportions, as well as a confidence interval for means. So we're going to use those two concepts, which we already know, to quickly go through this lesson. So just to recap from chapter 5, these are the parameters for a sampling distribution and the difference of sample means. Remember, the center is the true population difference, and the standard deviation is the formula as follows. This is from chapter 5. The sampling distribution, this is basically everything from the last slide, except this has been done in words, right? The shape we can assume is normal when both sample sizes are greater than or equal to 30. That's really important for us because of the central limit theorem. If not, we need to assess normality based off of a dot plot from our sample or a normal probability plot. The center, like we just said, is the difference of the true, and the standard deviation is the formula that follows. Don't worry about this. This is for a significance test, but that's the two sample t statistic. When we're constructing a confidence interval, we have these three conditions. They are the same, right? We need to be random, we need to deal with less than 10%, and we need to assume normality. Remember, do not use a two sample t procedure if the graph shows skewness or shows any outliers, right? We need the sample size to be greater than 30. If it's not, we need to assess for normality. Do not use if we show skew or outliers. Those conditions are the same. Now, the degrees of freedom, this equation looks very terrifying, but trust me, you will never use it. When you are calculating the t distribution to use, this is the formula that your calculator will use to calculate which t distribution to use. The degrees of freedom is given by this formula. Your calculator will do this. Do not worry about this at all. If you are doing it by hand, just to be conservative, take your two sample sizes, right? You're going to use the t distribution with degrees of freedom equal to the smaller of the two sample sizes minus 1. With this, it's just going to allow us to be more conservative in the area that we're using for our distribution. So always pick the smaller sample size and pick your t distribution based off of that. So the formula for a two sample t interval for a mean is as follows. This is very similar to what we've been doing before. We have our point estimate. We have our critical value. And we have our standard deviation of the statistic, also known as the standard error. Same formula, same construct, what we've been doing before. When we are going to our calculators, because mostly you will do this on a calculator, it's in the same place where you found the other t interval, right? This time you're just selecting two sample t interval. If you are asked for a pooled selection, click no. Click no. So let's do our one example for this problem. The Wade Tract Preserve in Georgia is an old growth forest of longleaf pines that has survived in a relatively undisturbed state for hundreds of years. One question of interest to foresters who study the area is, how do size of longleaf pine trees in the northern and the southern halves of the forest compare? To find out, researchers took a random sample of 30 trees from each half and measured the diameter at breast height, DBH, in centimeters. Here are comparative box plots of the data and summary statistics from the Minitab. So I just want to make note really quick that we have a random sample of 30 trees for each. We'll use that to check our condition. And here's our problem. Based on the graph and the numerical summaries, write a few sentences comparing the size of longleaf pine trees in the two halves of the forest. So let's start there. Let's look at these two distributions and describe them. Remember, when we describe a distribution, we need to use SOCS. So for the northern trees, the distribution is skewed right with no outliers. The center of the data let's say is about 18. With a range spanning from, let's see, what can we say? About 4 to 60. Right, those are just estimations. Let's talk about the north or the south. The southern distribution is skewed left with no outliers. The center is about 38 centimeters with a range spanning, looks like spamming, with a range spanning from, I'm going to say 4 to 55. If I wanted to, I could have actually given the standard deviation that's in our output here, right? We're given the standard deviation and we're given the average, right? I wanted to give the center, not necessarily the average. These are skewed, so I don't want to use mean as a measure of center. B says, construct and interpret a 90% confidence interval for the difference in the mean DBH of longleaf pines in the northern and southern halves of the Wade Tract Preserve. So I need to determine, do I want to do north minus south or south minus north? If I look, south is actually greater than north. So just to make sure that I'm dealing with a positive confidence interval, I'm going to do south minus north, right? If I did north minus south, I'd get the same answer. It would just be inverted. It would be negative. So let's do south minus north. So let's see what we're doing. I'm going to construct a 2-sample T interval where, or I'm going to say T interval for mu s minus mu n, where mu s is the true mean DBH in centimeters, and mu n is the true mean DBH in centimeters. Now I need to check my conditions. Is it random? Yes. We had an SRS of 30 trees. Is it independent? We can say yes, easy to assume more than 300 trees in each half of the forest. Can we assume that it's normal, right? We already talked that the distributions were both strongly skewed because N1 and N2, or sorry, let me use the letters, N and NS are greater than or equal to 30, by CLT, we can assume normality. So We've stated what we're doing. We've checked our conditions. Now we get to do it. Now remember, this is going to look like x bar s minus xns. That's my point estimate, plus or minus my critical value for a 90% confidence interval. That's going to be done in our calculator, times, I'm going to do ss over ns plus Sn over Nn, right? Remember, N and S refer to north and south, right? It may have been easier to do numbers. So I'm going to plug this into the calculator. Let's go ahead and plug it into the calculator, new share. Let's start with the nSpire. Right, so I'm going to go to menu, statistics, confidence interval, 2 sample t interval. We're dealing with summary statistics. We can plug in all of our information. So my first sample, which is the south, the standard deviation is 14.26. Sample size is 30. For the north, 23.7. 17.5, sample size of 30. I want a 90% confidence interval, and I do not want pooled. Select no for pooled. And there we go, there's our interval. Let me go ahead and copy that down. 3.94 to 17.72. If you were to do it on the 84, it is exactly the same. Input the same information. I'm going to just save some time and finish off the problem. Now we need to conclude. We are 90% confident that the interval of 3.94 to 17.72 centimeters captures the true difference, the true mean difference, sorry. Let me do true mean difference. Of trees DBH from the north to the south. Let's rewrite that better. We're confident that the interval captures the true mean difference of south and north, southern and northern trees DBH in centimeters.